Hey guys, this is our first video. The first thing we're going to talk about is real numbers. A real number is any number that can be written into decimal. Basically, any number you've ever dealt with. The only thing that's not a real number is an imaginary number, which is the square root of a negative. So all numbers that you've pretty much ever dealt with are real numbers. Within the set of real numbers, we have the set of natural numbers, which is also called counting numbers. And within the set of, including the set of natural numbers is the set of whole numbers. The only difference between these two sets is the number 0. Whole numbers are simply counting numbers plus 0. Integers are all positive and negative whole numbers. So negative 10, negative 100, negative 1,000,000, those are all integers because they are negative whole numbers. These braces, you have to get used to using those. Those tell you that you have a set. It's used to enclose the elements or objects of a set. The rational numbers are the next one down after integers. A rational number, and this is the notation you'll see a lot in math moving forward, it's read as a divided by b such that a and b are integers and b is not equal to 0. Basically, a rational number is any number that can be written as a fraction. Any decimal that repeats or ends is a rational number. There's a button on your calculator. I have to figure out how to get the TI-84 in here. There's a button that says math, and when you push math, then there's a button that says frac. That will allow you to convert from fraction to decimal and decimal to fraction. So let's say you have 6.175. If you put that in your calculator and then don't hit enter, just hit math, frac, enter, it will convert it to a fraction for you. And that's a rational number because it ends. This is what we were just talking about. The decimal form of a rational number either ends, like 1.75, or repeats infinitely, 36363636. The only numbers that are real but that are not rational are irrational numbers, and those are basically the square root of anything that's not a perfect square and pi. Let me say that again, that's kind of important. An irrational number is the square root of anything that's not a perfect square. Let's talk about what is a perfect square. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Those are all perfect squares. If I take the square root of any of those numbers, I'm going to get an integer as an answer. If you take the square root of any number that's not a perfect square, your answer will be irrational. When you put it on a calculator, it will look like this. It will never end, it will never repeat. That is an irrational number. So the best way to remember them is irrational numbers are pi and anything, the square root of any number that's not a perfect square. These are just some simple rules for you. If a and b are real numbers and a is bigger than b, sometimes it helps with these to plug in numbers so that you actually understand what's going on. So if a is bigger than b, let's call a 7 and b 3. A minus b, 7 minus 3, is positive. Obviously, if a is greater than b, a minus b is positive. The reverse is true if a is less than b. If you switch a and b here and make the a 3 and the b 7, then when you do a minus b, you get a negative number. If a is greater than or equal to b, it's either positive or 0. Less than or equal to b, negative or 0. These little symbols are called inequalities. I'm pretty sure you know that by now. The inequality x is less than 3 describes all real numbers less than 3. All real numbers less than 3. That means rational, irrational, anything less than 3. The double inequality, that's this guy, is all real numbers. When the x is written between the two inequalities, then we say x is between -1 and 4, including 4, because that little line underneath says 4 is also a potential answer. So, oh geez. That's how you would describe. Now to graph this, well, I guess we'll get to that in a minute. We haven't talked about interval notation yet. Well, we should. Interval notation, this is how you've always seen inequalities written up till this point in your life, for the most part. What we're going to do now is start writing it using more mathy notation. So x is less than 3. If 3 is here on the number line, instead of an open circle and shading, we're going to use a parenthesis and an arrow. So that says x is less than 3. For -1 to 4, we're going to go like this. Here's -1, here's 4. We're going to go with a parenthesis on -1 and a bracket, and these should actually be on the line. I shouldn't do it up here. Let's go like this. Parenthesis on -1, bracket on 4. The bracket tells you that the 4 is included, kind of like the closed circle. The parenthesis tells you that the -1 is excluded, kind of like the open circle. Okay? Write an interval of real numbers using an inequality and draw its graph. So here's the interval. Between -4 and -0.5 looks like this, and then the graph would look like this. Both parentheses, because there's no, it's not less than or equal to, it's just less than. And then for x is greater than or equal to 0, that's going to be a bracket on 0 with an arrow to the right. As shown in example 2, inequalities define intervals on the real number line. We often use this notation as well to describe the bounded interval between 2 and 5. Again, since it's equal to, we use brackets. If there was no line underneath, those would be parentheses. This interval is closed because it contains both endpoints. There's 4 types of bounded intervals. A bounded interval is one that has an endpoint. 2 endpoints, sorry. That's a bounded interval, one with 2 endpoints. So here we go. It's called closed if both endpoints are included. It's called open, this is how we write it, with brackets. It's called open if neither endpoint is included. So parentheses over here, parentheses on the number line. It's half open if only one endpoint is included. So here, if it's A, then we put see how A is less than or equal to? We put a bracket on A. Since B doesn't have an equal to sign underneath, parenthesis on B. And the opposite for this one. Include the B, don't include the A. That's what it means to be bounded, 2 endpoints. The interval of real numbers determined by the inequality x is less than 2 can be described by the unbounded interval. And this is how we write x is less than 2. From -infinity, -infinity all the way to 2. That's all the numbers less than 2. It's open because it doesn't include its endpoint 2. We use the interval notation to represent the entire set of real numbers, -infinity to infinity. That's how you say all real numbers. Sometimes you see all real numbers written like this. That's also how you say all real numbers, but this is the most common in pre-calculus. -infinity is all the way to the left on the number line. Positive infinity is all the way to the right. There are 4 types of unbounded intervals. When you see it written like this means that it includes A, and it goes all the way to infinity. It's a closed interval. It's a closed unbounded interval, not to be confused with a closed bounded interval. It's a closed, unbounded interval because it includes its endpoint, but it goes on forever. An open, unbounded interval does not include its endpoint and goes on forever. So unbounded means one endpoint, bounded means two endpoints. Convert interval notation to inequality or vice versa. So for letter A here, we're going to say -6 is less than or equal to x because it has a bracket, so that means it's included, is less than 3. It is bounded and it's half open because it only includes one endpoint. If you were to put it on a graph, it would look like this. Okay. B goes from -infinity to -1, so we write x is less than -1. We don't write greater than -infinity because every number in the world is greater than -infinity. So x is less than -1, not equal to, because it's a parentheses, not a bracket. We would draw that on a number line like this. And that is unbounded and open. Unbounded and open. And finally for C, from -2 to 3, they both have brackets. And it looks like this. That is a bounded and a closed interval. And we would write that like this, -2, 3. Okay? It's kind of confusing when you have one like this, from -2 to 5, because it looks like it should be a coordinate, because it's in parentheses. It depends on the context. If they tell you the interval, -2 to 5, then you know this is not a coordinate. It means all the numbers between -2 and 5, not including -2 and not including 5. These are all the properties of exponents. You've learned these before. It's really, 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 really important in math that you understand these properties. So basically, if you have 5 to the 3rd times 5 to the 4th, you add the exponents and you get 5 to the 7th. That's what this property is telling you. Or in other words, x to the 5th times x squared equals x to the 7th. Add the exponents. When you divide, you subtract the exponents. X to the 9th divided by x to the 4th is x to the 5th. Anything to a 0 power is 1. Anything. A negative exponent means to move it to the bottom, do the reciprocal. So y to the -3 becomes 1 over y to the 3rd. This one, the exponent belongs to both members of the parentheses, so you have u to the m, v to the m. So this is really tricky when you get numbers in here, because you have to do 2 to the 5th and z to the 5th, which becomes 32z to the 5th. When you have one exponent inside and one exponent outside, that's when you multiply the exponents. So this becomes x to the 6th. And here, again, the exponent on the outside belongs to both members in the parentheses, so you have u to the m divided by v to the m. So a to the 7th divided by b to the 7th. This is really, really, really important that you review these and get familiar with them, because they are going to show up a lot. I think that means I am done. I missed the one about all the properties. I'm not sure how that happened. But here's what you have to remember. Commutative property. Commutative property. Oopsies. Is when you reverse the order of things, but they're still true. So a plus b equals b plus a. It can also be said that a times b equals b times a. Commutative property works for addition and multiplication. The associative property changes groupings. it says that if you have A plus B and you do that first and then add C, you get the same answer as if you add B and C first and then add A. So order doesn't matter, is what the associative property says, as far as which one gets done first. That works for multiplication as well. So those are the properties. I think that's pretty much it. We are going to do a lot of examples in class, so if you suffered through my voice for this long and you took good notes, you are going to be just fine when we do this in class. Have a good night.